Everyone has their own definition of work, but to a technician, work is an efficient use of force that causes some kind of change in a system. We have seen that the definition of work for a machine can be quite different than that for a human. A machine is at work only when it's moving. Whereas people are at work all day long. Work in a technical sense is done only when a change is happening, when something is moving or changing shape. Two things are needed to do work: force, or something that acts like force, and the amount of change, such as the distance. People, on the other hand, feel like they're working as long as they're exerting force, whether it causes a change or not.
Just hold it a while. Hold it. Oh, okay, let her down.
But force alone is not enough to do work. So even if voltage, force, pressure, or torque are present, they do not do work unless they cause a change. That change could be the flow of electric charge caused by the voltage, the movement of an object caused by force, the flow of a volume of fluid by pressure, or the spin of an object caused by torque. No matter how powerful they are, if there's no change, there's no work. Work is not just a measure of force, it's a measure of exactly what force does. Work is always done on something. Force does work on an object, moving at a distance. Torque does work on an object, causing it to rotate through an angle. Pressure does work on the fluid. And voltage does work on electric charge, causing it to flow through a circuit. Whether that change happens quickly or slowly doesn't matter, because the same amount of work is done if the force and the distance are the same. When there's a job to do, we need to know two things: how much work will it take, and what machine can do that amount of work. We can then match machine to the job most effectively. This is what a mechanic does when selecting the right tool for the job. Robots, for example, come in a variety of sizes and types, and are capable of doing many different kinds of work. But robots are expensive machines, so the decision whether or not to use a robot is based on measuring work. The amount of work that needs to be done is compared to the amount of work a robot can do. If a robot cannot do enough work, it'll break down too often. Likewise, if it's too large for the job, it will not be working to capacity. This is called job efficiency, comparing work. And if a machine doesn't do a job efficiently, it can always be replaced by a human. Comparing work is easy to do because the units of work can be converted. For example, a foot-pound can be converted to a Newton-meter, so the work in a mechanical system can be compared to the work in a fluid system. Likewise, the electrical unit of work, the joule, is exactly equal to the Newton-meter. So even though moving an electric charge is very different from moving a solid object, the amount of work in the two systems can be compared. For example, robots have 3 different kinds of work taking place at the same time. Electrical work runs the hydraulic pumps. They create pressure and do fluid work moving the pistons, which then do mechanical work moving the objects. By comparing the electrical work in to the mechanical work out, we see how efficient the machine is. Robots tend to be fairly good. A car, on the other hand, is rather inefficient.
Okay.
Pressures in the engine do fluid work on the gases, which then becomes torque and does mechanical work turning the wheels. But when we compare them, the wheels are only doing about half as much work as the engine. The rest was lost as heat. Machines are nothing but oversized tools. Measuring work not only shows us what force can do, it helps us choose the right tool for the job.
Work, 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 work.
This program was produced at the facilities of Telemation Productions and is part of Principles of Technology, a project of state and provincial vocational and technical education agencies in association with the Agency for Instructional Technology and the Center for Occupational Research and Development. Together, serving education.